say here one illustration. Under this illustration, let set A elements are of 1, 2, 3. Then now let us find out the A cross A. Then that is equals to set consisting 1, 2, 3 cross, then set A consisting the elements 1, 2, 3. Then now, so here the relation, we are going to suppose the relation as R, then the relation R is equals to set of ordered pairs or nothing but the Cartesian product of A and as well as A. So here the relation R will be equals to one, 2, 3 cross 1, 2, 3. It is nothing but the Cartesian product of the two sets. Then now, so that implies the elements of this relation are of, so here 1, 1, 1, 2 and 1, 3. Similarly with 2, so here 2, 1, 2, 2 and 2, 3. And with 3, 3, 1, 3, 2 and as well as 3, 3. So here from this relation, that is relation R is consisting the number of elements as 9 elements, because here there are of 9 ordered pairs. So here because the elements of the first set are of 3 and the second set are of 3, this is of 9, there are of 9 elements that as the ordered pairs. So here in this I am going to suppose 3 conditions, that is relation number 1 consisting only, so here 1, 1, 2, 2 and as well as 3, 3. So here from this it is clear that the first coordinate of the first ordered pair is of 1 and the second ordered pair and the first ordered pair's second coordinate is also of 1. That is, the coordinates of every ordered pair are of equal in the R1 relation. So here the first ordered pair, the second ordered pair, so 2, 2, the first coordinate and the second coordinate are equal, and similarly in this third order pair, the first coordinate and the second coordinate are also equal. So from this it is clear that the coordinates of every ordered pair in relation, that is R1, are equal. Therefore, the formula in R1 is of equal to. So here, therefore, formula in R1, the relation R1 is equal to, that is x coordinate is equals to the y coordinate in the first order pair, similarly and so on. The first coordinate is equals to the second coordinate in the third order pair. So here we are going to we have used the formula in the R1 as is equal to. Then now let us support the second one, that is R2, second relation consisting the elements. So here 1, 2, 1, 3, 2, 3, then now in this case, so here the first coordinate is of x and the second coordinate is of y, but the first coordinate in the first order pair is of 1 and the second coordinate, that is y coordinate is of 2, that is 1 is less than 2, that is x coordinate is less than y coordinate in the first order pair. Similarly, x coordinate 1 is less than the second coordinate 3. So 1 is less than 3 and 2 is less than 3. So here the formula which is applicable in this second relation is of less than. So here first coordinate is less than the second coordinate, that is x less than y. So, here first coordinate of an ordered pair in second relation, that is R2, is less than the second coordinate, that is y coordinate. So, from this it is clear that similarly and so on in the second ordered pair, first coordinate, that is x coordinate, is less than second coordinate, that is y coordinate. So, here from this it is clear that the formula which is used in this R2 is of is less than, then the next logical step will be of hence the formula for second relation, that is R2, is less than. So, similarly in the third case, so here we are going to consider the third relation as R3, that is equals to say here 2 comma 1, 3 comma 1 and 3 comma 2, 2 1, 3 1 and 3 2. So, in these three ordered pairs, the x coordinate in the first ordered pair is of 2 and the y coordinate is of 1, that is x coordinate 2 is greater than 1, x coordinate is greater than y coordinate. Similarly, 3 is greater than 1, that is x greater than y. So, here x greater than y in the third case also, because 3 is greater than 2. So, in this case the formula in R3 is of greater than. So, here the first coordinate in an ordered pair of relation R3 is greater than second coordinate. So, here similarly and so on in each and every ordered pair, say it is the same process, the first coordinate is greater than the second coordinate. So, here the formula for R3 is of is greater than. Then now so here domain and as well as range of a relation. So, here now we are going to discuss about the domain and range of a relation. The set of first coordinates of all the ordered pairs in the relation, when we suppose the relation as R, the set of first coordinates of all the ordered pairs of a relation is said to be called as the domain, and similarly the set of all the second coordinates of all the ordered pairs of a relation, when we denote it by means of R, is said to be called as the range of the relation. Then now first of all, let us know the definition of the domain. It is nothing but the set of first coordinates of all the ordered pairs, that is OPs, of a relation So generally relation is denoted by means of R is called the domain or in other words domain of the relation R. Then now the second one, that is the range. It is nothing but the set of all the second coordinates of all the ordered pairs. The set of second coordinates of all the ordered pairs of relation, that is R, is called range of that particular relation R. So here let us illustrate this both domain and as well as range by means of one problem. So here one example. Under this example we are going to suppose a relation, that is if R, the relation is equals to ordered pairs of this relation are of 1, 2, 2, 3, 3, 4 and as well as 4, 5. So there are of 4 ordered pairs in this particular relation. Then now here we have to find out domain and as well as range of this particular relation. Then now the solution starts. So as per the problem, the relation which is given to us is of, so here R is equals to set consisting the ordered pairs 1, 2, the second ordered pair has 2, 3, the third ordered pair has 3, 4, the fourth one has 4, 5. Then now here, so we know as per the definition of the domain, so domain is equals to set of all first coordinates. So here the first coordinates are of 1, 2, 3 and 4. So here domain is equals to 1, 2, 3, 4. Then now, so here as per the definition, the range of this R is equals to the set consisting the second coordinates. So here the second coordinates are of 2, 3, 4 and 5. So therefore 2, 3, 4 and 5 are the elements of the range of this particular relation R.